the Arduino workshop by IEEE, we're going to be using the Arduino Nano today. And so the goal of this workshop was we're going to use the Arduino Nano to go ahead and work with the ultrasonic sensor to kind of create a stoplight. So who has used an Arduino before, like a full one? Huh? Okay. So the Arduino is a microcontroller which you can use to distribute power and also to modules to be able to make them work efficiently and use one central hub. And so the Arduino Nanos are actually a small version of the full Arduinos. We usually use these because they work the same, a little bit less power, but they're a lot cheaper. So if you ever want to buy something for yourself, Nanos are the way to go. And so here we're going to see the actual pins of the Arduino Nano. Now it may look a little bit overbearing at the moment, but really we're only going to be using about 5 of these pins, 6 or 5 of these pins, and I'm going to go ahead and say whichever ones we need once we continue. Okay. And so what we're going to be using today is 1 nano, one computer, 1 ultrasonic, 1 breadboard, 3 LEDs, 3 330 ohm resistors, and jumper cables, which I'll handle the jumper cables once we actually start making the circuit. Okay. And so I know also I'm kind of going a little bit fast because we do only have an hour, but if y'all want more info about specific stuff, just let me know after. And so after you open the actual Arduino IDE, we're actually going to go to this little panel up here, and you're going to click the Arduino Nano. Let me hand out these cables real quick. And so the cables you have right now, feel free to take them out and connect them to the actual Nano device from your computer. Okay. Yeah.
You know that you guys are going to combine, right? The joins.
Yeah, you told me.
Okay, just want to make sure.
I know we're also running kind of quick, so I'm going to go through it. Cool. John is coming over here. He's the other IEEE member. I kind of forgot to introduce myself. I'm sorry. My name is Matthew. I was trying to speed by too fast. So go ahead and get the jumper cable you have right here. It'll look like this. Go ahead and take it out. Does anyone need one? Do you need one? A jumper cable? Yeah. And so once you get this out, feel free to connect it to the actual Arduino Nano like this into this little slot, and then go ahead and connect the USB to your computer. Or really any power source you have, so you can also use the school one that you have right there, if you don't want to use your own. Here you go. And let me get you this. Hey, John. Okay.
Figured it's easier.
Here you go. And then I'm going to give you some of the other stuff. I'm going to some of those. Okay. And so after you go ahead and plug into the computer and everything, it'll make this step a little bit easier because it'll automatically detect what kind of machine you're using and what kind of port you're going to be using for it. So this should be at the very top of the IDE, and make sure it says Nano, or else it won't really connect to the right machine. Yes. I'm gonna, Johnny, do you mind handing out the rest of the stuff for the?
Yeah.
Very cool.
What do you need?
Yeah, so basically the whole kit, except for the Arduino on the breadboard. Okay. And so this is really how to see what COM port you have. So if it doesn't automatically register what communication port you're going to be using, yes. It'll. There you go. Yes.
Is this enough or do you need more? And then maybe the edges. Do you need more or is that okay?
And then the resistors too.
Yeah.
Cool.
Which ones are?
Okay, so has everyone been able to connect to the Nano, show that it's working, the COM port? Okay, perfect. Okay, so now we're going to move on to actually making the hardware part.
What values are you using?
330.
330?
Okay, so we're going to start on the hardware part. Right now, this is just basic what it's going to look at the very end. But it'll look a little bit different in person. So one, we're going to be using the breadboard. So to explain the breadboard, it allows power to run through a line, a row, and then you have the terminal strips on the side, which allow it to run through a column. But remember, in the middle where it shows the rows, it's only a row. Okay. So then we're actually going to be connecting all the hardware right now, the LEDs and the resistors. So if you look at this right here, we have the LEDs. We have a cathode and an anode, which is the positive and a negative. So if you look at the LEDs, the longer side is going to be the positive. So that's going to go onto the actual board. And the shorter side will go into the power rail where it shows the negative sign. You need some more clarification? Okay.
Yeah. So for the LED, right? Okay. I guess, sorry, what part is connected to you? The whole thing? Okay. So basically with an LED, you have two sides. You have a long side and a short side. So the long side will be your positive and the short is your negative. And then so the way you kind of connect it is your power will go through your positive and then it'll go out negative. So it's always positive to negative. Am I wrong?
No, you're right.
Sure. Yeah.
And then we need the resistors and the ultrasonic.
And then so, yeah, so that's connected to your resistor and the long side. Oh, no, do you have questions or? Sure. Yeah, so basically it's going to be connected to your resistor and then the short side will be connected to ground. Did you explain ground?
Yes, so the ground is going to kind of be what the circuit uses as 0 volts. So it actually doesn't blow up the poor thing. So here we're going to see ground is the blue rail right here where it shows the negative sign. So that short side that you have is going to be inserted into that negative rail right there. And then the positive is going to be into the actual board, into the middle. So you might need to stretch it a little bit.
Okay.
Mhm. The longer side? The first row is fine. It's whichever row you want inside the middle. The Arduino IDE. So if you look into your browser, it's going to be the Arduino IDE. It should be the first one that pops up. And so after you put in the LEDs, you're gonna put in the resistors, which are the tiny little guys that we gave you. And so we're gonna work off kind of that concept where power runs through the whole row. So we're actually gonna be able to connect 2 different sides of the board using that. So you have to make sure each resistor lines up with where you put that long side of the LED, and it goes into the other side of the board. Like this right here. Okay. And of course, you can put the ultrasonic wherever you want. It's kind of based off what you want to do, so feel free. And has everyone been able to put in the resistors?
Resistors are on the positive side, right?
Yes. Yeah, it's going to be on the positive. It does better. So the reason why we have the resistors is because if power comes directly into an LED, there's a possible chance that it'll actually, blow. So it'll kind of be a useless LED at the end of the day. So that's why we want the power to hit the resistor first and then flow into LED.
So positive with resistor to LED to ground.
Perfect.
Positive, positive,
And okay, so I'm gonna start explaining the actual where all the power is gonna come to. And so on the Arduino Nano, you're gonna see the little pins on the actual thing which say ground and V in. So if you're looking at it straight, where the circle is where the ground and V in is gonna be. Hello, how's it going? Yes. The Arduino. The Raspberry Pi, we actually merged. Yes.
So what are we doing for the setup?
The setup we're going to be using, should be making this right here. So it's going to be using an ultrasonic sensor, an Arduino Nano, and it's going to work off, change the LED lights, if it works.
Okay. Do you have a kit?
Yeah, let me get you here.
So there's no Raspberry Pi workshop today?
No, we were supposed to have it, and then the first like 15 minutes, no one really came, so we combined them.
That's the one I was excited for.
I'm sorry, man.
Tragic. I mean, I've worked on Arduinos, but it's been a couple of years.
Mhm.
So I guess how are y'all showing everybody? I guess since I'm still the first 20, right?
Yeah.
Are you doing like a step by step?
It's a step-by-step simple circuit, and then programming it to kind of detect everything and go off of that.
Okay. All right.
So, go and sit anywhere you want. There's a Nano. And so one thing about this is that we're going to actually connect the ground pin to that negative rail that we attached all the short sides of the LEDs to. And the power is going to go to that red little sign, which will allow power to run through that whole power rail. Yeah. So actually with those, with the jumper cables, we're going to connect it to the pin directly on the Nano and then to the board.
Do you have the other one? This guy.
Anybody have any questions so far with the power? No? Okay, perfect. Okay. I know some new people came in, so we're going to kind of play some catch up and then we'll move forward. But this is where all the pins are going to go. So here we're going to have to look at the actual pins that we see on the Arduino Nano. And so one side you're going to see all the Ds. And then if you look at the actual ultrasonic sensor, you're going to see some words on it that show the VCC, trig, echo, and ground. Yeah, so you're going to be using those to plug in.
I was looking at the folder. You said you have smaller?
So this is the Pi 02W. It's pretty small, but he's pretty good for like embedded system stuff. I will say that if you're looking to do like a lot more server-centered stuff, definitely
Yep.
get like the more full-fledged models.
Yeah.
Because it can
This
be
is just something for you to practice on.
Yeah,
But
like-
you got an SD card with it?
yeah. So SD card is here. It's already flashed.
Yeah.
And so all you just need is put a monitor in. So, yeah,
That's pretty sweet.
yeah.
Alright, so do you have a USB?
Yeah, should have it with me. Actually, I can try and put it up.
Yeah. Yeah, I was always wondering, I was like, well, if I was gonna create like my own like web server or something at home
Yeah.
on a string sheet budget, kind of Tony Stark it, you know what I mean?
Yeah, no,
And just,
for that, Pi's definitely are the way to go.
yeah. But you know, it starts with getting practice. You know, before I go buy. I mean, they're cheap anyway, but you know, before I buy one, I was hoping to get that workshop so I could play with. But it's what it is. Mind if I look at it?
Yeah, go for it.
Sorry, I like to tell you.
Take your time.
Okay, so
like the old phone chargers kind of
That's
thing.
micro.
Micro. Yeah. So you got the micro, and then you got the
So one is for
oh, this is HDMI. Oh shit.
yeah, but you can control internet so you can plug it into this.
Oh yeah, that's probably a lot more safer.
And then one of those ports is for connecting your mouse and keyboard,
Right.
and the other one is just for
A mouse on this. Oh, where's the USB? I don't see it.
so what you can do is
Is there a micro version of that too?
see there's a port you can do. So there's like an adapter you plug in.
Oh, adapter. So you got the mouse, keyboard, and then visuals for the HDMI. And then this one is.
Go back to.
I'm trying to think how you would connect to this.
Is everyone good on this hardware part? Does everyone's kind of look like this?
You're gonna be doing it in OS and stuff.
Good.
So,
Good.
are you
Cool.
familiar with OS at all?
Not on Raspberry. Is it Linux based or Unix? I guess.
It's like a custom one. I can't remember if it's actually Linux based or not, but it's basically a custom OS that they got.
It's all good. If you don't mind, I want to take a picture of this just for reference. I really can't wait to get one of these. Really? And it comes cables included and all that. It's been no solder. Is that what you just said? Heck no, man. You have to do all that. Wait, so what kind of peripherals are you gonna add to it, or like?
So it's like the same thing. So you can enable to do things like sensors and stuff like that. It just makes it.
Oh, so there's a breadboard for it.
I think of it like you're just putting these things in. It just makes it. So same here, but instead, some of them keep going solid like this. This one.
I would love to get to practice that. I don't know what extra tools you need like solder, but would you just go to Lowe's for that or something? I hope it's pretty straightforward. I don't want to like start doing everything back.
I would definitely try it.
But do you have any YouTube guys you follow? Maybe? Maybe that's taking some time on campus.
So it's like all of them, but there's a lot of really great. So there's this search of like something better, and you find like a lot of
Okay. So let me ask you this: what project did you like? Have you done any like big projects with, or are you just kind of playing, taking turns? You handle that? Oh, okay. So when you talk about, I don't know all the different Matthew sensors. So you're doing this for projects. Is there one that you, I guess, can you kind of give me like the fifth grade version of what you're trying to do with this? That involves embedded systems. I'm familiar for containers. Yeah. Right.
So right now that's kind of what we're doing at the moment. So we can walk through and make very easy.
Okay.
And then using the latest timer just in that environment. So it's all in space, and then we're using another board that works with that stuff. So this guy, oh no,
And that's a Raspberry or Arduino, or is it just the?
it's like a custom board. So, but it works with Linux. So if you're doing Linux-based stuff, this is good for that.
Sweet.
But yeah, so it works pretty similar to like Arduino.
So is it going to be like you have something programmed, if it senses something and then it goes to that and it's going to some other program runs? Is that kind of how that works?
You can do that. I think for our project,
And just real quick to look at the hardware again, the pins. That's technically what's going to be like.
Well, I could ask you like 1,000 questions.
Yeah, how's it going?
I'm gonna do some research on this.
How you doing?
For today, just to keep it on.
We're running low on nanos right now. But if you want to pair up with
Let's see, what are we trying to build right now?
you can see if this one works.
Something else. So they like didn't have enough people to do the Raspberry Pi one, so it's just already but
Yeah.
they got some good stuff. That's cool.
If y'all want to pair up,
Yeah, we'll pair up.
okay, cool. Okay.
Does anyone need help? Or do you need help?
A lot of them, I've been talking to them. If you want to see how their groups are doing, it's just the hardware part, kind of.
Okay. I'm gonna set one up and you just came in. So I'm thinking if I'll ask them if they want to do an ESP one, or if they just want to do their one.
We'll finish Arduino and we'll have them come to us after for the ESP.
Yeah.
That'd be a little better, because the ESP will take too much time to explain.
Do you think you're almost done with it, or still got right
When you study the software.
Yeah.
The hardware part's the hardest part, though. 'Cause I'm gonna put on the software part. So whoever wants to start a little bit of coding, go ahead. And then whoever needs some hardware, I can go and help with the hardware. So once you open up the Arduino IDE, you're gonna see just kind of a blank screen. This is the very beginning. So this actually defines all the pins that you're gonna use. So feel free to type this in. We're gonna be using all the trig pins and the different names are up to you. You can name whatever you want that makes sense to you, as long as the number stays the same, because the number signifies what pin we're going to use on the nano board. But the name is arbitrary.
Let me know if you need help.
I might need a bit of help, yeah.
I'm gonna set them up real quick.
Okay. Sandra? Sandra? Let, let me know when you get this one. Okay. Okay, there you go. What part did I leave off on for you? This one good?